Welcome. Today this video is going to talk about the rules for exponents when we're dealing with positive exponents. Exponents are the way that we write repeated multiplication. When we have 3 times 3 times 3 times 3 times 3, we can write that using an exponent rather than just writing out a string of numbers. So exponential notation involves a base number and some exponent. The exponent tells us how many times we're multiplying, and the base tells us the number that we are using to multiply. So for instance, in expanded form, we have 3 times 3 times 3 times 3. This is expanded form. 3 to the 4th is exponential form. There are 5 rules that we worked with in this lesson. We have the product rule, the quotient rule, the product power rule, the power rule, and the quotient power rule. Notice that in each of these rules, we have either the same base or 2 different bases to the same exponent. For the power rule and the quotient rule, I'm dealing with the same base raised to an exponent, and then there's some sort of operation. In the product rule, it's a multiplication. In the quotient rule, it is a division. You might see this as x to the 3rd times x to the 4th. We could take the x base, add the exponents of 3 plus 4, and we would get x to the 7th. The reason this is true is because x to the 3rd means that I'm multiplying x 3 times. X to the 4th means I'm multiplying x 4 times. And if I count all of those up, I have 1, 2, 3, 4, 5, 6, 7 total. With the quotient rule, I'm going to use my x to the 4th and x to the 3rd as well. In this case, I have x to the 4th over x to the 3rd. I keep the base. I don't simplify x over x to be 1. I keep the x. And then I subtract 4 minus 3 to get x to the 1st power. This is because x to the 4th can be written as x times x times x times x over x times x times x for x to the 3rd. And then I can cancel x over x because that's 1, and I am left with a singular x. So the shortcut is the subtraction here. The third rule that we have that has the same base is the power rule for exponents. Let's say I have x to the 3rd to the 4th. This is not multiplying x to the 3rd times x to the 4th. It is raising x to the 3rd to the 4th power. That's telling me to repeat x to the 3rd 4 times. That's x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. And then if I apply the product rule, I would add that 3 4 times to get x to the 12th. Essentially, I am just multiplying whatever my exponents are. The product power rule involves multiplication of 2 different bases raised to the same power. For instance, I could have 2x to the 3rd. That is the same thing as 2x times 2x times 2x. That gives me 2 to the 3rd power and x to the 3rd power. I can distribute in that 3rd as my shortcut. 2 to the 3rd is 8 if I wanted to evaluate x to the 3rd. When I have this multiplication inside the parentheses, the exponent applies to both of them. The exponent does not apply in an addition problem. 2 plus x to the 3rd is not equal to 2 to the 3rd plus x to the 3rd. If you don't believe me, feel free to expand that out and multiply. You're going to get 4 terms, not just these 2. Okay, so this is bad news bears. All right, lastly, we have the quotient power rule for exponents. I'm going to take my 2 and my x again. If I have 2 over x to the 3rd power, That's the same thing as 2 over x 3 times. 2 over x, 2 over x. And we can see here that we get 2 to the third and x to the third. The shortcut again is to distribute that in. Now, I might have to use the power rule with the quotient if I have x squared over y to the third raised to some power. In this case, again, I'm going to distribute in that 4, but my final evaluated simplified answer would be x to the 8th, y to the 12th. Those are the 3 rules we use for positive exponents. It can be a little bit trickier if I give you a problem where there's multiple operations all in one, but that's the general idea of the rules that you will see. Thanks for watching.